Hello, this is Dr. Chauhan, and in this video I will explain the concept and the calculation of the p-value in a simple setting. P-value is used in hypothesis testing process, and its value is used in making decision. In a hypothesis testing, a very simple example, we have two opposing statements. One statement is called the null hypothesis, and it is denoted by h of 0. And this statement is generally about population value being equal to something. So in this example, our null hypothesis is that the population mean, mu, is equal to 20 ounce. So perhaps a company manufactures a product and it is believed that the mean weight of a product is 20 ounce. Another statement, which is called the alternative hypothesis and denoted by h of 1, is that perhaps the company believes that the mean has changed and it is now more than 20 ounces. So now we have two statements. Null is that mean is equal to something. Alternative in this example is that the mean is bigger than 20 ounces. And the idea is that we will take a random sample from this population, examine the sample and decide whether the sample supports the null hypothesis or the alternative hypothesis. So here is the logic of hypothesis testing, that if null hypothesis is true, then the sample mean, if you take a random sample and calculate the sample mean, under the null hypothesis, the sample mean should be close to 20 ounce, because sample mean and population mean are expected to be close. But if sample mean is significantly higher than expected value of 20, then we will reject null hypothesis and we will establish the alternative. So now we collect the data. So let us suppose that we took a random sample of 36 products and we calculate the sample mean. And let's suppose that the sample mean is 22 ounces. Let us also suppose that we know that the standard deviation is 4 ounces. We remember standard deviation is a measure of variability. Not all products will have the same weight. So sigma, it is the population standard deviation. In this problem, it is known to be 4 ounces. So now the question is, our X bar is 22 ounces. Expected value was 20. Is this significantly high? Is X bar significantly high? Well, how do we decide if it is significantly high? In statistics, we calculate the probability or the likelihood of the occurrence of an outcome. So what I would like to calculate is that if the null hypothesis is true, if the population mean is actually 20, what is the likelihood that X bar could be as high or higher than 22? Why higher? Because 22 is on the higher side, higher than 20. Expected value was 20. So the question now is, what is the probability that null hypothesis is true and X bar could be 22 or higher? Well, since X bar has a normal distribution because n is large, we can change this value 22 to a z-score. How? Well, from 22, I will subtract the mean, which is 20, and I will divide by the standard deviation of X bar, which is sigma over square root of n. So that's how we change this 22 to a z-score. And if you do this calculation, it turns out to be that we are calculating the probability that z is greater than or equal to 3. How do we calculate this probability? Well, one way is to read the normal table, or you could use the graphing calculator. This is a typical graph of z-scores, mean being 0. So the question is, well, what's the probability that z could be as high as or higher than 3? From the normal table, that probability turns out to be 0.13% or 0.0013. This probability is called the p-value. So what is the p-value? P-value is the probability of observing a result as high as or higher than what we have observed if the null hypothesis is true. So this probability is low. What does that mean? What it means is that under the null hypothesis, what we have observed is highly unlikely. That means null hypothesis and what we have observed, they don't match. One has to be incorrect. But what we have observed, so we cannot deny that. So because what we have observed is very unlikely under null hypothesis, we reject null hypothesis and conclude the alternative is true, which is that mu is bigger than 20. So now the question is, well, our p-value or probability, which was 0.13%, how do we know it is low? Do we have a guideline? And the answer is yes. Generally speaking, if the probability of an outcome is lower than 5% or 0.05, we consider that probability to be low. But our p-value was, remember, 0.13% or 0.0013. Obviously, it is a lot lower than 5%. By the way, this guideline that we select in advance is called level of significance, which is generally 5%. So that's the concept of p-value. Now let me mention one thing which is also very equally important is, let's come back to this number, sigma. Sigma is the population standard deviation. Often population standard deviation is not given. So that means that when we take a sample of 36 observations, we not only calculate the sample mean, but we will also have to calculate the sample standard deviation. And if that's the case, some of the steps will change. So let us suppose, for the sake of argument, that from 36 observations, when we calculated the mean, we also calculated the standard deviation, but I'm going to use the letter S because that is from the sample. And let's suppose that that S was also 4 ounces. They don't have to be equal, folks, but this is just one number I have selected in an example. Now, how would I know in a problem that it is S and not sigma? Well, if you read the problem, it would say that the sample standard deviation is 4 ounces, or it would say population standard deviation is 4 ounces. So it will be mentioned in the problem. So let's see what changes that will break. Question is still, is X bar of 22 ounce significantly high? Again, the probability that we are calculating is the same. Is X bar, what is the probability that X bar could be as high or higher than 22? We will change X bar again to a standard value by subtracting the mean, dividing by the standard deviation. But remember, this S, this 4 represents S, not sigma. And as a result of that, this quantity that we have standardized is no longer called Z, it is called a T value. So now the question is, what is the probability that a T score is bigger than 3? And that means we will now read the T table. The T graph is very similar to a Z graph, folks, although the actual shape depends on the sample size. So now we will read the T table. We have discussed in the class how to read the T table. But as a refresher, we will read the T value or the area above 3 with 35 degrees of freedom. So where did that 35 come from? N is 36, so the degrees of freedom is 36 minus 1, which is 35. So from the T table, this area turns out to be 0.0025, roughly, or 0.25%. Is this probability low? Yes, it is low, lower than 5%. So our decision will still be the same. What we have observed under null hypothesis is highly unlikely, so the null hypothesis should be rejected. Now in my next video, I will show you another example in which we will calculate the p-value if the alternative is that mu is less than a given value. So the logic would stay the same. It's just minor changes because the calculation, we will have to read the table slightly differently, so that would be given in the next video. So thank you very much, and I hope this was helpful.